for some practice problems on individual demand. So our first thing to do is to fill in the table. So marginal utility, the change in utility, for the third unit, we went from 36 to 50, so that was a change of 14. Now the total utility for the fourth unit, well, we started with 50, and our marginal utility, the extra utility from consuming the fourth unit was 12, so the total utility must be 62. And then we can fill in, this is a change of 10, 8, 6, and 4. And over here, well, if we started at 26 and our extra utility was 10, we get to 36. And then this is a change of 8, 7, 6, 5, 4. So that is our missing marginal utility and total utility values. And now we want to find her optimal combination. So we have three ways to do this. I'm going to go through all three. So first of all, with method 1, we want to figure out all the combinations she could do. So if she had no popcorn, she could have 8 candy, or she could have 1 and 6, 2 and 4, 3 and 2, or 4 popcorns, and then she wouldn't have any money left over for the candy. So her total utility here would be 66, just 8 candy. 1 would be 20 plus 57, 77. 36 plus 44 is 80. 50 plus 26 is 76. And then 62. So the optimal combination is 3 and 2. I'm sorry, 2 and 4. That gives us a total utility of 80. Now to use methods 2 and 3, we're going to need to calculate marginal utility per dollar. So for popcorn, the price is $1. We divide these numbers by dollar. I mean, I couldn't write them down again. It's 2016. Here we're dividing by 50 cents. So we have 28, 24, 20, 16, 14, 12, 10, and 8. So for method 2, we're going to spend all our money and choose the thing that gives the highest marginal utility per dollar. And that is, let's see, we're going to get first candy because 28 is higher than 20. And again a candy because 24 is higher than 20. Then we have a tie. And then another tie. And we've spent all the money. We spent $2 here and $2 here, $4. We're done. So our quantity of popcorn is 2. Quantity of candy is 4. Same as what we saw with method 1. They agree. With method 3, it's the same thing. 20 and 20, marginal utility per dollar is equal, but we haven't spent all the money. 16 and 16, they're equal, and we have spent all the money, and that's our combination. There's other good combinations here too, like 12 and 12. That just costs too much. You can't afford that. Or 8 and 8. Other combinations with marginal utility per dollar equal. Those are good, but they're not in the budget. So that is question 1. Question 2, we have no choice but to use method 3 because we just don't have all this like utility information for different levels of consumption. So the price of the tennis is $2, the price of the comic book is $1, so marginal utility per dollar. Well, the marginal utility of the tennis was 16 divided by the price of the tennis was 2. That's for tennis. And then for comics, the marginal utility was 20, and the price was 1. And so we can see that 20 is much bigger than 8, so it's not optimal because marginal utility of the tennis divided by the price of tennis is not equal to the marginal utility of comics or the price of comics. So what should she do? She should buy more comics. When she does that, she's going to take, let's say she takes $2 away from the tennis and spends the $2 on comics, she's going to increase her utility, because she's going to trade something that gave her 16 units of utility for something that gave her 20 units of utility. Well, you know, more than 20, because she would get maybe 20 for the first comic book and then 18 for the second, or 15, something less than 20, but still much better utility from comic books at this point than from tennis. And so she should buy more comics, switch from the tennis to the comic book, switch from something that gives you a lower marginal utility per dollar to something that gives you a higher marginal utility per dollar. When she does that, you know, her marginal utility for tennis will go up because she's going to those earlier sets of tennis that she enjoyed more. Her marginal utility for comics will go down because she's consuming more, and it's like these later ones aren't as great until they're equal. And so, you know, as long as they're not equal, buy more of the one that has a bigger marginal utility per dollar. And then when they're equal, you know that you're at your highest point and there's no adjustments you can make that would increase your utility. So let me know if you have any questions about the worksheet.